Internet Protocol version 4 or IPv4 design. In this video, I'm going to talk about IPv4 design. Actually, at the first step of IPv4 learning and also learning about the design of IPv4, we are talking about the IPv4 header. This is the first step. Actually, one of the most important features related to IP or Internet Protocol is the header of IP. Because of that, at the first step, we should know about different fields and multiple fields that we have in the IPv4 header. Because of that, first we are starting our knowledge or learning about the IPv4 design with the IPv4 header. You know that according to the TCP/IP model, okay, IP or Internet Protocol is a protocol that is working in the layer 3 of the TCP/IP model. And also, you know that IP is the abbreviation of IP or Internet Protocol. And also, we know that the transport protocols means TCP and UDP. Okay, TCP is the abbreviation of Transmission Control Protocol, and UDP is the abbreviation of User Datagram Protocol. Okay, should create a segment. And after that, the segment should be sent to the IP or Internet Protocol. As you can see here, TCP and UDP should send their segments to the IP. And after that, IP should create the IP data or packet or datagram. We call it packet. Actually, when we are giving the, for example, segment to the IP should give us packet or datagram. You know that IP is described in RFC 791, and IP was prepared for the Defense Advanced Research Project Agency or DARPA in September 1981. Now let me to explain the IPv4 header. Here we have one simple scenario. I have configured this simple scenario. We have two router 1 and router 2. I'm going to use this simple scenario only for verification of the IP header. You know that this is the IPv4 header. I will explain all of the fields in this video, and also all of the fields in this, for example, header. Let me first emphasize that the IPv4 header is 20 bytes actually in length. Actually, IPv4 header without IP option, okay, has 20 bytes. And when we are adding IP options for some specific reasons, maybe the IPv4 header size is increasing. Because of that, until now, we have learned that the segment should be sent to the IP, and after that IP create the packet or datagram. And we know that one of the most important features that we have in the IP is the IP header, and now we are talking about the IP header. IP header without IP options and also padding has 20 bytes length. Look at here. Here we have 20 bytes length, and it means that we can say the IP header in most cases has 20 bytes in length, but in some rarely cases that we have IP option field and also padding, maybe the header of IP is increasing about the size. Okay, now I'm going to show you first one simple IP header, and after that we will learn about the content of the IP header. It is so easy and also so interesting. Look at here. For example, we can capture the link between the router 1 and router 2. It is so easy. And then we can send a traffic from router 1 to router 2, or if you want, you can use telnet protocol to send telnet session from R1 to R2. Let me to use, for example, ICMP or ICMP echo request, router 1, ping 10.122. Now we have connectivity. Okay, and this is the result of our capture. Let me to stop it here. You can see we have ICMP echo request and then ICMP echo reply. Here we can see the packet. This is for example, Internet Control Message Protocol or ICMP. ICMP is a protocol that we have in the layer 3, and it should send its traffic, it should give its traffic to the IP. Here you can see that we have ICMP, then IP, then Ethernet, and this is the layer 1. As actually Actually, here we can see the content of this, for example, data. Then here on the Internet Protocol version 4, we have some information. Here you can see these informations here. Let me to compare the header of IP that we have captured with this figure. Look at here. We have the first field, the version, I will explain it, and then the internet header length, IHL, and after that here we have type of service. This is the type of service. Actually, here we have two fields, differentiated service code point and ECN. Both of them, okay, are calling the type of service or TOS. This is the new name of TOS. I will explain it. After that we have total length, and then we have identification, and then we have flags, and then fragment offset, then time to leave, after that protocol, and after that for example header checksum. Then here we have source IP, destination IP, and this is the real data. You know that here we don't have IP option field and padding. Only in some rarely cases we can see the IP options and also padding. I will explain them. For now, let me to start talking about the different fields that we have in the IP header. The first field is the version. As you can see, version has 4 bits length. Look at here. Here we have 4 bits length. Okay, and here we can experience one of these two value. The first value is the 40, okay, as 110. 0110 is equal to the 4, and also it is possible that we see for example here 0100 means 4, and also it is possible to see 0110, it is equal to 6. What does it mean? With version, actually we can understand this is the IPv4 header or IPv6 header. I will explain the IPv6 header in future videos. Now we are talking about the IPv4. Because of that, we expect to see always in these 4 bits, in these first 4 bits, the value of 0100. Actually, with these 4 bits, the receiver can understand this is the header of IPv4 or this is the header of IPv6. Let me to show you the, for example, version. Here in the capture file, this is our capture, we can see that in version we have 0100. It is so easy. This is the first step, and we know that it indicates the IP headers format based on the version number, and we expect to see 0100 for IPv4 and 0110 for IPv6. This is the first field that now we know about it. Look at here, this is the version. Alright, now let me to explain the next field. The next field is IHL or Internet Header Lengths. As you can see here, again we have 4 bits, okay? And this field IHL indicate the length of the header in 32-bit word. You know that if in IP header we don't have IP options, the length of the IP header is 20 byte, okay? I have explained it before. Because of that, here maybe you expect to see the value of 20, but actually here we can see the length of the header in 32-bit word. 32-bit means 4 byte. Actually, because here now the length of this header is 20 byte, we expect to see the value of 5. Okay, 5 means 0, 1, 0, okay, 1. It means that here now we have the value of 5, and 5 means 20 byte, okay? And because at least we expect to see 20 bytes, the minimum value in the IHL, okay, is the 5. And if we have option fields and also padding, we will experience the values more than 5. Here, let me write here, this is the version 0100, and then in IHL we expect to see now 0101 means 5, but 5 multiply 4 byte equal to the 20 byte, and this is the length of the header. Don't forget, this is only the length of header, not the data. Actually, when we are, for example, sending ICMP, let me to show you, this is our ICMP, okay, and after that we have ICMP echo request, and after that we have 20 bytes IP header. We are sending this packet to the router 2. Router 2, after for example verification of this field, the IHL field, can understand after which number of bytes, okay, it can reach to the data data, to the real data, to the ICMP. For example, it knows about the start of the IP, and it knows about after, for example, 5 multiply 4 means 20 byte. Okay, it can reach to the real data. It is so useful. Let me to show you the value of IHL. Here you can see that the value of IHL